Every August, the Perseid meteor shower delights skywatchers everywhere. While some years it's a disappointment, either being washed out by a bright moon or delivering a relatively sparse stream of particles for Earth to collide with, other years the show is spectacular. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. This year, in particular, a minor but significant enhancement is occurring. The orbit of Jupiter gravitationally influenced the stream of particles we're colliding with, causing the center of the stream to collide with Earth. Although many of us will enjoy the 50% or so enhancement in the rate of meteors, it brings up an uncomfortable reality. It's possible that one day Jupiter will gravitationally influence the comet that gives rise to this meteor shower and cause it to collide with Earth. First, the good news. The motions of planets and comets are very well calculable, and this particular comet 109P/Swift-Tuttle has its orbital properties very well known and understood. Every 133 years, it makes a complete orbit around the Sun, coming about 8 million kilometers, 5 million miles, anterior to Earth's orbit, yet reaching farther away from the Sun than even Pluto does at its most distant. It last entered the inner solar system in December of 1992, and won't do so again until 2126. Its next 2,000+ years of orbits are mapped out incredibly well, and the Earth is 100% safe until at least 4479, when it will come quite close to Earth once again. Even then, there's still a 99.9999% chance it will miss us. But with every pass into the inner solar system, there's a chance that one of the gas giant planets will influence this comet's orbit. There's a chance that, just like the Perseid stream was thrust into Earth's orbital path this year, someday in the future, this comet will achieve a collision course with Earth. Each orbit contains, on average, a 0.000002% probability of the comet hitting Earth. This might seem small, but it's 6 times greater than your odds of winning the Powerball. Only in this case, it would be the ultimate cosmic loss. Comet Swift-Tuttle is 26 kilometers in diameter, making it 260% the width of the asteroid that wiped out the dinosaurs, and it moves at 4 times the speed that the dinosaur killer moved at whenever it crosses Earth's orbit. Put all that together, and a direct impact would cause approximately 28 times as much energy to be released as the most massive extinction event of Earth's past 100 million years. The way scientists classify the likelihood of a collision between an asteroid or comet and a planet is by measuring its MOID, or the minimum orbit intersection distance. If these were the only 2 objects orbiting the Sun and there were no mutual gravitational interactions between anything else, how close, given enough orbits, would this comet close to us? The answer is a frighteningly low 0.000892 AU, where anything less than 0.05 AU is deemed as potentially hazardous. That corresponds to a minimum distance of just 133,000 kilometers, which is only about a third of the Earth-Moon distance. In fact, if we query the NASA Solar System Dynamics database and ask it what all the objects are that are larger than just 50 meters and will pass within 0.001 AU of Earth, we find that there are only 4. And the other 3 are slow-moving asteroids no larger than 400 meters across, while Comet Swift-Tuttle is 26,000 meters across. Any of the others would be enough to cause tremendous regional devastation, destroying a city if it collided with one, causing a tsunami 10 times as destructive as the one that famously hit Japan in 2011 and resulting in a crater the likes of which Earth sees perhaps just once every 100,000 years. Such a strike would be 10 to 100 times more destructive than the meteor strike that created the famed meteor crater in the southwestern United States. Yet if Swift-Tuttle were to strike Earth, it would release more than 1 billion megatons of energy, the energy equivalent of 20 million hydrogen bombs exploding all at once. Without a doubt, the comet that gives rise to the Perseids is far and away the single most dangerous object known to humanity. We have a few thousand years of surefire safety ahead of us, but subsequent to that, gravitational interactions are unpredictable and could lead to the greatest collision in Earth's history since the creation of our moon. So enjoy looking up at the Perseid meteor shower this and every August, and when you do, think about how fortunate we are that this comet has missed us in every orbit up until now. Someday, unless we continue to get very, very lucky, this meteor shower may become a portent of humanity's and possibly life on Earth's demise. There are things out there in the vast universe that are potentially life-threatening. The malignant universe is full of objects that could destroy not only civilization but the entire solar system. Earth is a small little world when compared to the entire universe, and wiping it off the face of space isn't as difficult as you think. With objects like black holes and neutron stars wandering close by, and by close we mean in cosmic terms light years, it isn't not hard to believe that our home planet could be under potential danger. Let's take a look at some of the scary cosmic monsters that are lurking around us. Rogue black holes. For those of you who don't know, black holes are colossal cosmic beasts, and once you're in one, there's no coming back. Their gravitational pull is so strong that anything that gets pulled in, beyond the event horizon, it can't escape, not even light. And because of the light-sucking void, they are not at all easy to spot in the vast darkness of space, and maybe hundreds around our galaxy. Rogue black holes, around 600 million times the mass of the Sun, are the ones that got kicked away when galaxies collide and are sent swirling into space at 9.5 million kilometers per hour. So basically, you can't see them, they're massive, they're fast, and they're coming to get you. If a rogue black hole is hurling towards Earth, it most certainly tear the solar system apart and slurp everything into its dark, mysterious hole. What happens in there is still a puzzle for scientists, but their best guess is being shred to pieces. If you're thinking about enormous galactic objects eating each other up, you're on the right path. Galactic cannibalism is when two galaxies merge with each other in a gigantic cosmic collision. This may seem exciting, but the bigger galaxy's gravitational pull would consume the smaller galaxy. Earth would most likely be thrown into the outskirts or be fried up by things like hypervelocity stars, huge stars that move at 1.6 million kilometers an hour. And just so you know, our Milky Way galaxy is on the course to collision with our neighbor galaxy Andromeda, which is, by the way, a lot bigger. That's right, in a couple billion years, we will be eaten. Here's where you would want to bring up the question of friend or foe. The sun, though providing us with heat and light and proving to be one of the essential things for life, has a dark side. First off, solar storms. Solar storms are radiation and streams of charged particles from the sun erupting surface. It wouldn't actually be a threat to human life, but it could potentially disturb our technologies like the one that hit in 1859 called the Carrington event. And once the sun's teenage years are over, the sun will swell up into a big red star called a red giant, which probably will swallow the Earth. Although we still have around 4 billion years before we have to worry about that, but it's going to happen. Gamma ray bursts. Gamma ray bursts, GRB, are one of the most powerful events in space, which happen with the collapsing of a supermassive star or collision of two black holes or neutron stars that are so bright we can see them for billions of light years away. You wouldn't want to be in its path when it goes off, though. If Earth turns out to be in the beam path, direction where the rays would head out, it would blast our planet with huge lethal levels of radiation and stripping away the atmosphere, which would eventually lead to mass extinction. A neutron star is an insanely dense star with all its mass crunched up into an area of about 15 kilometers, which means it's pretty darn heavy. Basically, a teaspoon of neutron star material would weigh about 10 million tons. A magnetar is a type of neutron star with an extremely powerful magnetic field. If it gets too close, the magnetic fields are strong enough to disturb your molecular structure, which means you would, in a way, dissolve. Two of them, though quite far, hit Earth without notice in the past. In 1979, the solar system was hit by the radiation of a magnetar that inundated the detectors of 3 U.S. Department of Defense Vela satellites, the Soviet Prognost 7 satellite, and the Einstein Observatory, and another in 2004 which penetrated deep into the ionosphere.
Yeah, yeah.